piece of work in 120 days and B in 150 days respectively. So when this fundamental data is given, you can decide whether you can find the LCM or not. Here you can find the LCM and you can decide the work into some units, is it not? What is the LCM of 120 and 150? 600. Therefore, the work is considered to be 600 units. Therefore, the work is considered to be 600 units. And you tell me whether a person is working individually or is working with somebody else, whatever work he can do per day, that much work only he will do, is it not? So what we do is, we will write down the individual performance of each and every person here. Now you tell me, who is responsible for completing the work, the total work? Who is responsible? A, B and C. A, B and C are responsible for completing the work. Now I will write down the participation of each and every person. In the first phase, A and B worked together for 20 days. Implies A did for 20 days and B also did for 20 days. Is it not? Individual I am writing their participation. After that what happened? B left. A continued the work alone for 12 more days. Isn't it? Then C joined. A worked for another 48 days. C also worked for 48 days. This was the participation of each and every individual. Now, totally for how many days A worked? 80 days. Along with B 20 days, alone 12 days, 48 days with C. How many units A can do per day? B. A participated for 80 days, per day 5 units. So how many units were completed by A here? How many units were completed by A? 400 units. Clear? All of you clear? Now, B participated for 20 days. How many units he can do per day? 4. Totally how many units he completed? 80. A completed 400 units. B completed 80 units. Out of 600, 480 were completed. How many units were left? 120 units. Who did these 120 units? In how many days he did? 48 days. So, for doing 120 units, C requires 48 days. For completing the total work means for doing 600 units, how many days he would require? Understand? For doing 120 units, 48 days are required by C. For doing the total work means for doing 600 units, how many days are required? More number of days are required. So more by less into 48. 125. 5 into 48 is 240 days. Don't allow the fractions to come into the problem. Once a fraction is coming in the problem means calculation will be more. Understand? This is the way if we can split the problem, if we can do, the concept is in your hands, any problem it takes the same time. Easily it can be solved. Okay. Next. Next problem. A and B, A and B can do a work in 30 days. A and B can do a work in 30 days. They both worked together for 20 days. They both worked together for 20 days and then A left. The remaining work was completed by B. The remaining work was completed by B in 25 days more. How long would A alone? How long would A alone takes to do the entire work? You see the difference. So far we did with units method. Here, what is the problem? Read the problem once. A and B can do a piece of work in 30 days. There is no second data available. After this data, the work started. So units method will not work out, because to decide the work into some units, you need another data here. Another data is not there. In such cases, as I told earlier, we go for the ratio method. A and B can do a piece of work in 30 days. They worked together for 20 days. They worked together for 20 days and then A left. Suppose A is not leaving the work after 20 days. In how many more days they will complete the work? 10 days. So, A plus B is a 10 days work. Because A left, B completed in 25 days. Is it not? It implies whatever work that A and B has to do in 10 days, B, because A left, B completed in 25 days. Work is constant here. When the work is constant, number of days ratio is 2:5 here. When the number of days ratio is 2:5, then the capacities ratio will become how much? 5:2. A and B are working with 5 capacities. B is working with 2 capacities. Therefore, the capacity of A is 3. So now it is very simple. Working with 5 capacities, the work can be done in 30 days. It is already given in the problem. A and B can do a piece of work in 30 days. In how many days A alone can do the entire work means, working with 3 capacities, how many days they will take to complete the work? Capacity is reduced means more number of days. More by less into 30. 3 10. So 5 into 10 is 50. So A alone can do the work in 50 days. So in case where you cannot decide the work into some units, switch over to this method. If you are perfect with this method and units method, any problem you can solve easily, right? And one more thing, A can do a piece of work in 10 days, B in 15 days. How long A and B can do the work? Otherwise, A can fill a tank in 10 minutes, B in 15 minutes. How long A and B can fill the full tank? Both are same, is it not? So water, tanks, pipes, all the problems are similar to the men and work. Okay, next problem write down. A pipe can fill a tank A pipe can fill a tank in 9 hours. A pipe can fill a tank in 9 hours. But due to the leakage in its bottom, it takes 1 hour extra for the tank to be filled up. But due to the leakage in its bottom, it takes 1 hour extra for the tank to be filled up. If the tank is full, in how many hours the leakage will empty it? If the tank is full, in how many hours the leakage will empty it? What is the problem given here? Assume that pipe A can fill a tank in 9 hours. Along with A, suppose B, a leakage pipe is also open in the bottom. Usually leakage pipe for washing the tanks we keep. So if this is also open, instead of filling for 9 hours, the tank is filled in 10 hours. It takes 1 hour extra. But what is the question? The question answer is, if the tank is full, how long will the leakage takes to empty? It means you will have to find the leakage capacity. Now, usually we decide the work as some units. Here, we decide the tank capacity. What is the LCM of 9 and 10? 90. So, the tank capacity is 90 units. If you want to fill up the tank, 90 units you have to fill. If you have to vacate the tank, you have to vacate 90 units. A. In 9 hours it is filling 90 units means 1 hour it fills 10 units. But when the leakage is opened, instead of 10 units, how many units are filled in 1 hour? 9 units. So how many units are going out per hour? 1 unit. So B capacity is, it will vacate 1 unit in 1 hour. For emptying 1 unit, it takes 1 hour for B. For emptying 90 units, how many hours it will take? More. So more by less into 1, that is 90 hours. It takes 90 hours for the tank to be empty. Next problem. Pipe A can fill tank in 4 hours. Pipe A can fill a tank in 4 hours and pipe B in 6 hours respectively. Pipe A can fill a tank in 4 hours and pipe B in 6 hours respectively. If they are opened, in alternative hours, starting with pipe B, how long it would take to fill the tank? How long it would take to fill the tank? Pipe A can fill a tank in 4 hours and pipe B in 6 hours respectively. If they are opened in alternative hours, starting with pipe B, how long it would take to fill the tank? See, instead of assuming 1 hour work, if you take units, you can decide there itself. 6 and 4 LCM is 12, so the tank capacity is 12 units. Oral problem. Tank capacity is 12 units. First B is opened and then A is opened and then B is opened and then A is opened. Alternate hours. First hour, A can fill 3 units and B can fill 2 units, isn't it? B filled 2 units. Second hour, A filled 3 units. Totally, in 2 hours, 5 units are filled, isn't it? So, after seeing this value, we will come to know about the position. 5 units are filled, still 7 units are to be filled. Again, next turn is B, again A, another 5 units. Now 10 units are filled for 4 hours. Next, whose turn? B. B will fill how many units? 2 units. Tank is filled, is it not? So in how many hours the tank be filled? 5 hours. Put it in units, easy to calculate instead of fractions. Next problem. A pipe can fill a season. A pipe can fill a season, CISTERN, in 16 minutes and another can empty it in 8 minutes. If the tank is already half full, and both the pipes are opened together, then the tank will be emptied or filled in what time? Then the tank will be Suppose pipe A can fill a tank in 16 minutes and pipe B can empty it in 8 minutes. What happened here? The leakage capacity is more. Suppose your father is earning 40,000 and your expenditure is 50,000. Then what happens means what happens? Minus. So if your father is a respectable man, what he has to do? First he has to earn some money, say 2 lakhs, 3 lakhs. He has to deposit in the bank. Then he should call you, come home. Then what he will do? His salary 40,000 plus 10,000 from the bank. 50,000 he will give. Is it not? So for that reason only, tank is already half full means tank is already filled with water because leakage capacity is more. See here, 16 and 8, the LCM is 16. The capacity of the tank is 16 units. A can fill 1 unit, whereas B can empty 2 units. Now, both are opened at a time. Both are opened at a time means what happens? That is the reason he told the tank is already half full means tank is already holding how many units of water? 8 units. Then what happens is 1 unit will be collected from A, 1 unit already reserved water. 1 plus 1, 2 units of water will go out. So every 1 minute, 1 unit from the old stock will go out. Like that, if you want to vacate all the 8 units, how many minutes are required? 8 minutes. So the tank will be emptied in 8 minutes. Therefore, tank will be emptied. Tank will be emptied in 8 minutes. Next. A and B. A and B can do a piece of work in 15 days. A and B can do a piece of work in 15 days. And A and C can do it in 10 days. All of them started the work together. All of them started the work together. After 3 days, B left. After 3 days, B left. 1 day later, A also left. The remaining work was finished by C. The remaining work was finished by C in 11 days. The work can be finished by A, B and C together in. The work can be finished by A, B and C together in. Do it. data given here, according to this data, with this data, how can you solve the problem? Here there is a possibility for determining the units of the given problem. LCM is 30. 15 and 10 LCM is 30 means the total work is decided as 30 units. A and B will do how many units? 2. A and C? 3. And who is responsible for completing the work? You write down first. What it is given in the beginning? All of them started the work together after 3 days, he said. So all the 3 days, all of them worked, is it not? So A worked for 3 days, B worked for 3 days, and C also worked for 3 days. After 3 days, what happened? B left. B left means A and C worked for one more day. Because again, immediately after one day, A also left. The remaining work was completed by C in 11 days. The remaining work was completed by C alone in 11 days. This is the participation of each and every individual. What we do? Individual, if you want to write down means individual units we don't know. Whatever the data available, we go with available data. See here, A and B work we know. Can I combine these two? 3 days, A and B completed how many? 3 into 2, 6 units completed. Clear? Again, what I can combine? A and C. One day, A and C, 1 into 3, 3 units completed. So how many units completed? 9 units completed. What were the remaining units? Remaining how many? Out of 30, 9 gone means how many? Who did these 21 units? How many days? 3 plus 11. 14 days. For completing 21 units, 14 days are required for C. For completing 21 units, 14 days are required. For completing total work means 30 units, how many days are required? More number of days are required. More by less into 14. 7 threes, 7 twos, 3 tens, 20 days. Now we got the data. A plus B can do a piece of work in 15 days. C can do it in 20 days. In how many days A, B and C all together will do the work? That is the problem, is it not? Question is that only. In how many days all the 3 together will complete? 15, 20 LCM is 60. 4 units, 3 units, 7 units. For doing 7 units, 1 day is required. For doing 60 units, how many days are required? More by less into 1. 8, 4 by 7 days. The time required for completing the work is 8 4 by 7 days by all the three, A, B and C. Adopt this method. The main disadvantage with aptitude is at least you are learning the methods, because we don't have time to do 30-40 problems in a chapter. You are seeing now, right from yesterday, we are not taking much gap also. Continuously we are doing also means, anyhow some small chapters will be there. You have to prepare on your own. Main topics will be covering. That the main concept, what I am trying to tell you is, I want you to understand the concept which we are adopting. Now you are clear about time and work. If you can solve any 20 or 25 problems from other textbooks, you will get clarity about this concept. Work out the problems, method you take this. Okay. So after lunch we go with time and distance. The concept is, when the distance is constant, speed and time are inversely proportional. That is the main concept in this, right? Suppose, for example, a person A walks with a speed of 4 kilometers per hour. If A walks with a speed of 4 kilometers per hour and walks continuously for 5 hours, what is the total distance that he covers in all the 5 hours? 20 kilometers, isn't it? Similarly, if B walks with a speed of 5 kilometers per hour and walks continuously for 4 hours, what is the distance that is travelled by B? Is also 20 kilometers. Why I have taken this example is, in both the cases distance is constant. When the distance is constant, it is observed that the ratio of the speeds as 4:5. Then what is the ratio of their time of reaching the destination? Is 5:4. From this we can clearly conclude that when the distance is constant, speed and time are inversely proportional. And the required formula is derived clearly here itself, because speed into time is equal to distance. Speed into time is equal to distance. If you want to find speed, that is distance by time. If you want time, that is distance by speed. And in the problems mainly, we come across two types of units. If the distance is in kilometers, the speed should be in kilometers per hour and the timing will be in hours. If the distance is in meters, the speed will be in meters per second. It should be in meters per second. The timing will be in seconds. And whether to convert the distance or speed, it all depends upon the problem. Suppose, for example, if I ask what is the distance between Hyderabad and Chennai, we will not say in meters, we say in kilometers. So distance you have to mention in kilometers, means speed should be in kilometers per hour and the timing will be in hours. That is the important point you have to remember. And in most of the problems, we go for speed conversion. Most of the problems related to boats and streams or trains, speed conversions we usually do. Speed, if it is in meters per second, and if you want to convert it into kilometers per hour, by what value we multiply? We multiply with 18 by 5. Meters we have to convert them into kilometers, then seconds to minutes and minutes to hours. It takes time. So constant value is given already. If you multiply by 18 by 5, it will be converted into kilometers per hour. In any case, if the speed is in kilometers per hour, and if you want to convert this speed to meters per second, from kilometers per hour to meters per second, if you want to convert, you will multiply by 5 by 18. This already you know all this information. And coming to the problems, particularly problems related to trains. How we take the problems related to trains? First we take the distance point of view, distance. Suppose, take distance, suppose a train of length 400 meters. If it were to cross an electric pole or a man or a tree, what is the total distance that the train has to travel? Means train has to travel its own length. Suppose a man is standing on the platform. If a train has to cross the man, it has to cross its own length. So the total distance to be covered by the train is 400 meters. Suppose a train is of length 400 meters. If it were to cross a bridge of length 300 meters or a platform of length 300 meters, or it were to cross another train which is standing on the other platform of length 300 meters. It means one is a moving object, the second one is a stationary. Now you tell me, what is the total distance that the train has to travel to cover this bridge or platform? 700 meters. So you have to consider the length of the train and also the length of the platform. That is 700 meters. Suppose a train is of length 400 meters and another train is going in the same direction with a length of 300 meters. If the speed of this train is more, this will definitely cross this. So, if this train were to cross this train, what is the total distance that this train has to travel to cross this train? What is the total distance to be traveled by the train to cross the other train, if both are traveling in the same direction? 400 plus 300, 700 meters. 700 meters is the distance to be traveled by the train. Suppose one train is having a length of 400 meters, another train of length 300 meters is coming in the opposite direction. If they are traveling in the opposite direction, at one or the other point they both will cross each other, isn't it? So if this train has to cross this train, what is the total distance that this train has to travel? How much? What is the total distance? 700 meters. Initially, while beginning, I thought unnecessarily this fellow is drawing, you may be thinking unnecessarily this fellow is drawing diagrams and telling we know everything, subtracted. You know subtraction, but where to subtract you don't know. As far as distance point of view is concerned, whether both the trains are moving in the opposite direction or they are moving in the same direction, or one train is moving, the other one is a stationary, whatever it may be, length means you will have to take the sum of the lengths here, irrespective of the direction of the train. So distance addition is important. Nowhere you will come across the subtraction. For that reason only I told the very basics of this. And coming to the speed point of view, speed. The speed when we are talking related to two trains, we call it as relative speed of the two trains. Relative speed. Suppose one train is traveling with a speed of 60 kilometers per hour, and another train which is already moving in the same direction with a speed of 40 kilometers. Because the speed of the second train is more, definitely it will cross this train. Relative speed means what is the speed that works out when one train is crossing the other train. So relative speed means don't calculate from the railway station. So while crossing each other, what is the speed that works out? So this train is already moving with 40. Another train is coming and crossing with a speed of 60. While crossing, this goes with 40 and this goes with 60. What is the difference? 20. So same direction means higher speed minus lower speed, that is 20 kilometers per hour. The speed is 20 kilometers per hour. Suppose a train is traveling with a speed of 60 kilometers per hour when water has no speed. In a well, the speed of the man is 4 kilometers per hour. In small ponds, the speed of the man will be 4 kilometers per hour. Suppose if you throw this man into a sea where water has speed, his speed depends upon the speed of the water. So, water is traveling with a speed of 2 kilometers, flowing with a speed of 2 kilometers per hour, and man is swimming in the same direction with a speed of 4 kilometers per hour. If both the directions are same, then we say this speed downstream. We say it as speed downstream. In problems, he will not mention like this. The speed downstream is 4 kilometers per hour. Means speed of the boat plus speed of the stream is 4 kilometers per hour. So speed downstream is equal to speed of the man. Speed of the man or boat plus speed of the stream or velocity of the stream or current of the stream, whatever it may be, speed of the stream. That is, speed of the man is 4 kilometers per hour, this is 2 kilometers, so 6 kilometers per hour is the speed that works out. Right? Suppose water is flowing with a speed of 2 kilometers per hour and a man is swimming against the flow of water. Against the flow of water with a speed of 4 kilometers per hour. This is called as speed speed upstream. Speed upstream. Speed upstream is equal to speed of the man or boat minus speed of the stream. That is 4 minus 2, that is 2 kilometers per hour. And remember one point always, that the speed of the man or speed of the boat should be taken first. Here in plus, in addition, you can take either way. You won't get any difference in the answers. But in minus, if you reverse this, the values may differ. So, first speed of the man or boat has to be considered. So, this is about speeds. And you observe, in trains, relative speed means in the same direction we have gone for subtraction. And in boats and streams, same direction means we have gone for addition. Why this change means, here man and water are, they depend on one another. The speed of the man depends upon the speed of the water here. Here, both the trains are traveling independently, not a train dragging the other train, isn't it? So that is the reason why we get the difference. So distance means whatever may be the distance and whatever may be the direction, addition. Speeds in trains we take like that. Speeds in boats and streams we take like this. And time means we have only one time, calculating the time. So time we don't have any separate calculation like this. But whatever may be the concept is when the distance is constant, speed and time are inversely proportional. That point you must always remember. When the distance is constant, speed and time are inversely proportional. And in the exam also, campus recruitment, distance is constant, concept is important. On this concept, the problems will be given, right? Write down one problem. Walking at 4/5 of his usual speed. Walking at 4/5 of his usual speed, a man is 10 minutes late. A man is 10 minutes late to reach his destination. His usual time. Read the problem once. He has neither mentioned the speed nor the time and not even the distance. What he said? Walking at 4/5 of his usual speed, a man is 10 minutes late. We will assume that a man is traveling a fixed distance every day. This is a regular question. A man is traveling a fixed distance every day. Say for example, he is traveling with 1 unit speed every day and reaching the destination in 1 unit time. One day what happened? Walking at 4/5 of his usual speed. 4/5 of 1 means 4/5 only. Speed is reduced. When he walks with a speed of 4/5 units, what is the time he will take to reach? What is the time he will take to reach? 5/4. Because when the distance is constant, speed and time are inversely proportional. 5 by 4 means 1 by 4. 5 by 4 means 1 by 4. Usually he takes 1 unit. Because he reduced his speed, he is taking 1/4 unit extra. That 1/4 unit is equal to how many minutes? 10 minutes. He is led by 1/4 unit and is led by 10 minutes. Means 1/4 unit indicates 10 minutes. Then his regular time, find his usual time means 1 unit will be equal to how much? 1 by 4 unit equal to 10 minutes means 1 unit will be equal to 1 by 4 means 4 by 1 into 10, that is 40 minutes. So regularly a certain distance at a certain speed, the man is taking 40 minutes to cover. Understand, this is the important problem because he has not mentioned the time, he has not mentioned the speed, he has not mentioned even the distance. But only one point we can say that distance is constant. Right? Next. Walking at 5 by 3 of his usual speed. Walking at man is 10 minutes early. His destination. Find his usual speed. Find his usual time. Find his usual time. See here. A fixed distance is traveled with a fixed speed and reaches in a fixed time. Walking at 5 by 3 of his usual speed. Speed is increased. Speed is increased means in what time he will reach? 3 by 5. 1 minus 3 by 5 means that man is saving 2 by 5 units. It's coming early by 2 by 5 units. This 2 by 5 units is equal to how many minutes? How many minutes? 10 minutes. Find his usual time means 1 unit will be equal to how much? 1 by 2 by 5 means 5 by 2 into 10. 2 5s. 5 5s are 25 minutes. So regularly he takes 25 minutes to cover that fixed distance. So distance is constant concept. This is the first model that you will have to remember. If at all he misses this model in the examination, then chances of asking the second model is there. Right? Write down the second model. A man while going to his office from his house travels with a speed of 40 kmph. And while returning home along the same route travels with a speed of 60 kmph. Find his average speed. Find his average speed for the entire journey. Find his average speed for the entire journey. See here, a man from his house to the office while going travels with a speed of 40 km/h. While returning home along the same route, I said, means indirectly I am saying that distance is constant. While coming back home, he travels with a speed of 60 km/h. What is the average speed for the entire journey? How much? 78, 28, 48. Actually, average speed means we have two formulae. Average speed means total distance traveled. Total distance traveled by total time taken. This is the formula. Average speed means total distance traveled by total time taken. The problem will be like this. A man traveled in the first 3 hours a distance of 90 kilometers. In the next 2 hours a distance of 60 kilometers. And in the last 3 hours a distance of 50 kilometers. Find his average speed. Suppose if the question is asked like this, then what we have to do is, total distance traveled is 90 plus 60 plus 50, 200 kilometers. Total time taken is 3 plus 2, 5, 5 plus 3, 8 hours. 200 by 8 means 25 kilometers per hour. So average speed is 25 kilometers per hour. But here in this problem, the required distance is not given, the required time is not given, except these two, the other data was given, speed was given. And the average speed you can calculate when speeds alone are given, but the condition must be distance should be constant. So when the distance is constant, speeds alone are given, average speed is equal to 2ab by a plus b. 2ab by a plus b means 2 into 40 into 60 by 40 plus 60 is 100. 0, 0, 0, 0. 48 kilometers per hour is the average speed. Don't calculate like while going 40, while coming 60, 100, while going 1 and while coming 1, 2, not the average speed. So, when the distance is constant, speeds alone are given, then the formula for average speed is 2ab by a plus b. This model is important. Regularly it can also be given. Suppose if the first model is missed and also the second model is missed, then third model, this is also distance is constant concept. Third model, write down. A boy while going to the school, a boy while going to the school from his house travels with a speed of 3 km/h. travels with a speed of 3 kmph and is late by 10 minutes. And is late by 10 minutes. However, if he travels with a speed of if he travels with a speed of 4 kmph, he is early by 10 minutes. Find the distance between his house and the school. Find the distance between his house and the school. See, either in the first case or in the second case, the distance between the house and school will not change. So distance is constant. What is happening? A boy is traveling with 3 kilometers per hour. He is reaching the school 10 minutes late. However, if he wants to go in time to the school, he will travel with a speed of 4 kmph. In such cases, he is reaching the school 10 minutes early. This is the condition given. Then what is the distance between his house and school? Straight away point, how much? 240 kilometers every day will go and come to the school. T1 minus T2. First point you can write down T1 minus T2. What is T1 minus T2? First day timing and second day timing. What is the difference? 20 minutes. School is at 9 o'clock means going late by 10 minutes means 9:10. Going early by 10 minutes means 8:50. The difference is 20 minutes. 20 minutes, I will put it in hours, 20 by 60 hours. Because we usually mention the distances of schools and colleges in kilometers. 20 by 60 hours. That is 1 by 3. The formula for time is distance by speed. Distance by speed 1 minus distance by speed 2 is equal to 1 by 3. Distance by speed 1 minus distance by speed 2 is equal to 1 by 3. I have not mentioned d1 and d2 because distance is constant. D by 3 kilometers per hour minus d by 4 kilometers per hour is 1 by 3. LCM is 12. 4d minus 3d is equal to 1 by 3. 3 will go 4 times. So distance is equal to 4 kilometers. So the distance between his house and the school is 4 kilometers. So if the first, second, third models, usually one model will come regularly, one problem.